Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nabila Syafiqah and my partner's name is Nurul Fadina. We are from Group A, AS2515D2, and we are going to present to you experiment 2, which is influence of solar radiation on PV output. The aim of this experiment is to identify the effect of solar irradiance on output of PV modules. The objective for this experiment is to measure solar irradiance using a pyranometer and to calibrate a PV module for solar irradiance measurement. The procedure for this experiment is this experiment is best done on a bright and clear day with irradiance value of about 500 watt per meter square or above. From the PV module's datasheet, the short circuit current at standard test condition (STC) and the temperature coefficient of short circuit currents values are recorded in table 1.1. The solar irradiance, DC currents, and module temperature (T modules) for all PV modules are recorded in table 1.2. For both PV modules without the pyranometer was placed together at another location without any shading. The IDC measured for both modules was measured and recorded into table 1.5.
Analysis. You can see here the data we had is at 7:40 a.m. and how we calculate the G calculate is by using ISC measured over ISC STC and times 100 and 1000 watt per meter square, and the ISC measured is 0.16 and ISC STC is 8.76 times with 100, we got 18.26 watt meter square. Next, we calculate ISC measured. How we calculate is by using PDC power over VDC voltage. PDC power is 70 while VDC is 439. So ISC measure is 0.16 ampere. Next, we calculate ISC calculated. We use IDC. Is IDC equal to IMP times F temperature times NP times F date times FMM times G over 1000. So F temperature is we got by calculating 1 plus gamma SC in bracket of T module minus 25. So we got F time equal to 1. Then substitute it to the equation, these equations, and we got 0.12 ampere. Next, we calculate the percentage difference. Percentage difference is 2 times ISC measured minus ISC calculated over ISC measured plus ISC calculated times by 100%. So ISC measured as we got is 0.16 and calculated is 0.18. So we minus over plus times with 100,000. So we got negative 12%. So next we can see this is table 1.1 of selected parameters of PV modules from datasheet. So for short circuit current we got 8.76 ampere. For temperature coefficient is 0.04. This is the unit. So for table 1.2 measured data, we have irradiance of G measured with watt per meter square and polycrystalline PV modules of ISC measured with ampere and T module of degree Celsius. So we collect 1, 2, 3, 4, 5 data with irradiance from 117, 118, 125, 135 and 145. For 117 G measured, we got current of 3.61 with temperature of 29, and as we can see, as the temperature increase, the the G measured also increase. When the G measured increase, the current measured also increase. So next we have table 1.3 of measured versus calculated value for polycrystalline PV module. So irradiance we have the G measured and G calculated, and ISC measured, ISC calculated with the percentage difference. So for when G measured is 117, as we calculated it, we got 412.10, and for ISC measured, we got 3.61, but as we calculated, we got 3.55. So the percentage difference is 1.57. Same goes to G measured. It is increased, while G calculated is also increased. 4.412.10, 415, 446.35, and for ISC measured, we got it more higher than ISC calculated. Next, it shows a graph of G calculated versus G measured. As we can see, when G measured is increased, G calculated is also increased. Next is G measured versus ISC measured. When ISC measured is increased, when the current is increased, the G measured is also increased. So hence, both of the graph are proportionally, directly proportional to each other. For the discussion, there are few formula that we use in this experiment, in this lab. First is ISC measured. How we calculate it is by using, as we all know, is P equal to IV, where ISC is equal to PDC equal to over VDC. Next is ISC. It can be calculated by using the IMP times F temperature times NP times F dirt times FMM and G over 1000. So next is percentage difference. It can be calculated by 2 times in bracket of ISC measured minus ISC calculated over ISC measured plus ISC calculated times 100%. So for G calculated, it can be calculated by ISC measured over ISC times 1000. So what the percentage difference is calculated in order to have the difference between two related value of ISC measures and ISC calculated. So the value obtained from G calculated are bigger than the G measured, and all the values that have been recorded are needed to be used in order to plot graph. So from this table we can conclude that when the G measure increase, the ISC measure is also increased. So from both graph before, we can conclude that the current increase with the increase of solar radiation. As the temperature increase, the solar irradiance also increase. Besides, the value of current and voltage can also be affected because of the module temperature due to the solar irradiance. So in order to do this experiment, you have to wear an appropriate attire because we have to do this experiment in field that had direct sunlight, so you have to wear appropriate attire in order to not be fainted. And before you do this experiment, make sure to always check the weather because it only can be done during sunlight or cloudy, but not during the rainy days. So from this experiment, it is important to calibrate the PV module before proceeding with the installation. So from the graph of G measured against ISC measured, we can conclude that the relationship between both is directly proportional to each other, and when G measured is increased, ISC measured is also increased. Hence, the objective of this experiment, both of the objective is increased. So to conclude, the solar irradiance affect the output of PV modules direct to their linear pattern. So that's all for me. Thank you.